Okay, so first let's discuss what is the difference quotient. Okay, so this is about 40% of this course. If you understand this, if you understand how to simplify it, you will understand a lot of at least derivatives, differentiation, etc., etc. So, very important. But first I would like to explain what it is. Because again, I'm the type of person that I ask why. And I'm sure you are too. Why do I need to know this? What does this mean? Where does it come from? And why do I need it? Okay, so let's take a look at the function. I'm graphing this function. Let's say it's f of x. And I have 1 point here and 1 point here. I'm going to call this point P. I'm going to call this point Q. And I'm going to say that this has coordinate x, and I would like someone to tell us the y coordinate of this point.
Like the value of it or where it is?
You will not be able to give me a value.
I didn't think so. I just very...
Right.
On the y-axis where you drew that line, isn't that where the y is?
Correct. Can anyone give me the y value in a different way? Other than y. Is there another way of saying what that is?
F of x?
Absolutely. So obviously if this is 5, who was that?
Oh, Brandon.
Thank you. So obviously if this is 5, what will this be?
5. F of 5.
Very good. If this is 3, can anyone say it again to make sure?
F of 3.
F of 3. Excellent. Now, Q is extremely close to P. Very, very close. Right here. But allow me to zoom in. Okay, otherwise I can't explain. So Q is very close to P. So I'm zooming in. So how close? X plus a little bit. H. A tiny bit. Tiny bit. Tiny. So Q is next to it. But I'm zooming in so I can explain what I'm doing. Can anyone give us the y coordinate of Q?
F of x plus h.
Excellent. Who was that? Thank you, Kim. Okay, perfect. So now I would like to do this. I would like to draw a line through these 2 points. This is called a secant line. Nothing but to do with trigonometry. It just says that this line crosses the graph in 2 points. It can be more, but at least 2 points. It's not tangent. Not tangent. What does tangent mean? This will be tangent. This is tangent. Nothing to do with trigonometry. It just says that the line and the graph share exactly 1 point. A secant line, the line and the graph share 2 or more points. Okay, we're going to talk about this very soon, but not in R, in chapter 1. Okay, back to our secant line. Can anyone give us the slope of the secant line PQ? I'm going to dig my notes from last time. Oh,
It'd be the change in y over change in x.
so this is what we did last time, and this is why we did it. Right? We did it for this. So we were given 2 points, exactly like in this situation. I'm given 2 points. This point is x comma f of x, and this point is x plus h comma f of x plus h. Given 2 points, exactly like here. And we were asked to determine the slope. So can anyone explain or dictate?
So f of x plus h minus f of x
Brilliant.
over x plus h minus x.
That's it. Done. Excellent. So can we, by simply looking here, can you say, yeah, you can simplify it a little bit? And tell me how.
You can, on the denominator, the x's cancel each other out.
That's it. There is only one fraction. There is only one denominator. So yes. So these two go away. And this is f of x plus h minus f of x divided by h. This is the difference quotient for the function that we have. Now, what does it mean? It's the rate of change, or I would say the average rate of change of f of x between p and q. P and Q. That's what it means. So this is carved in stone. This is the definition of the difference quotient. And we will choose different functions to determine and simplify the difference quotient. So give me a quadratic function. Anyone make up a quadratic function?
X squared plus 2x plus 4.
Perfect example. So we want to find the difference quotient plus simplify it. So this is what we're trying to do now. We want to find the difference quotient for this function that we just created. And then we want to simplify the difference quotient. Ready? Okay. So let's first of all start by writing the difference quotient. F of x plus h minus f of x divided by h. For the next few months, please make this your second nature. So I have the function. I see in the difference quotient 3 pieces. I see this piece, I see this piece, and I see this piece. Would you agree?
Yes.
Perfect. Okay, now which of these 3 pieces I do not have?
H and h plus, or f of x plus h.
Right. This is the only piece I don't have. This is a poor beat, a little bit. Nobody cares. There is nothing I can do to it. This is the only one that I do not have. This I have, no, nothing, no one can change those. So this is my starting point.
Would
So-
we find it by doing, by replacing x and the f of x with parentheses x plus h
Brilliant.
and expanding?
Thank you very much. Thank you, Brandon. Excellent. So now I replace x by x plus h. But let me explain, because not everyone, I haven't heard from everyone. So I'm not sure if everyone is paying attention or understands this. So let's take a look at this function. Here's what I see. This is what I see. So who gave us this function? Was it Mallory?
Yes.
Perfect. This is what Mallory did, even if she wasn't aware of it. But this is what she did. She said f of blah equals blah squared plus 2 times blah plus 4. And then brilliantly Brandon said, okay, if you want to find f of x plus h, what's the big deal? Just plug in x plus h in here. But I just want you to understand why and what the pattern is telling us. Okay, at this point, we're going to find f of x plus h. I'm going to write it again here, exactly as Brandon said, and as Mallory created the function. And now, who would like to tell us what, other than Mallory and Brandon, which I heard from, how many terms we get when we square x plus h?
3.
Yes. Can anyone else give us those 3 terms? Anyone?
It's x squared plus 2hx plus h squared.
Brilliant. Thank you, Rachel. So 2x plus 2h and plus 4. Okay. So all this work was for this. Now I have these 3 pieces to put together to find this. Are you with me, everyone, please?
Yes.
Yes.
Yes,
Yes.
perfect, awesome. So then the difference quotient. Please watch me, I always run out of room because I write big. So I'm replacing this piece first with all this. So x squared plus 2xh plus h squared plus 2x plus 2h plus 4. I reach the minus that has sign that has to be distributed to f of x. Can anyone tell us what to write next for the minus this with no parentheses? Just go ahead and...
X squared plus 2x plus 4. Well, we minus it. I'm sorry.
Minus x squared minus 2x minus 4.
Very good. Over, of course, over h. Now, stop. And let's talk about this. 2 things have to happen for all difference quotients. Note. 1, all terms without h from the numerator. Must cancel. What do I do if they don't cancel? I go back to the drawing board. I have a huge error somewhere. They have to go away. Some terms with h may go away too, which is a bonus. But all terms without h must cancel. If they don't cancel, I made a boo-boo somewhere. Note number 2. H in the denominator after note number 1 is in effect. Note number 2, that's why this is 1 and this is 2. This is first and this is second for a specific reason. H from the denominator must simplify. For all difference quotients, for all functions, no matter what. If these 2 do not happen, I'll say, oops. Cross out everything and start from scratch. So now I will continue. Let's take a look. Negative x squared, positive x squared, negative 2x, positive 2x, negative 4, positive 4. How many terms are left at the top?
3.
Very good. All
And
terms
H
without
can be
h.
Cancel out of all of them?
Yes, so all terms without h went away? Yes?
Yes.
Good. So now h from the denominator. So from here, you will see me do this a lot. So you know where, because I don't want to write this again. So this circle means that I continue here. So this circle continues here. The numerator has 2xh, h squared, and 2h. What is the common factor that has to be pulled out? Please do not simplify in here, please.
H.
H will go away. And now you can simplify, but not inside there. Please don't do that. That's not correct work. Okay, can anyone give us those terms here that are left over?
H plus 2x plus 2.
Yes, so 2x plus h plus 2. And this is the rate of change of this function between f of x plus h, the point with f of x plus h, and the point with f of x. Okay? So this is the difference quotient. Fully simplified, and no one can simplify it further. And you will see in chapter 2 what this, in chapter 1, where does this lead to. Okay. So I did not select a particular problem because we chose something else. Okay. So I'd like to look at some functions, some graphs. Which graph is a function? So do we remember which graph is a function? By the
Vertical line test?
By the vertical line test. Of course, this is not a function, it's a vertical line. All these are functions. This is not a function. 48 is not a function by the vertical line test. And all the others are functions, except the vertical line, of course. Okay. Now, I said that I would continue with another example with a piecewise defined function. Do we need to? We had an example last time. You had a homework to turn in today. Are we okay with that? Can we move away from it?
Yes.
Okay.
Yes.
Okay, perfect then. What else I wanted to do here? Notice that I did not give an example. I just want you to know that compound interest can be determined continuously and n times a year. I did not give an example of this kind. Why? Because we are going to talk about the exponential function in detail in chapter 2. Okay, that's why you didn't see an example like that. And yes, so we do have here another compound interest, but I think we got the idea. We already used that. I don't see anything else, so please take a look at anything from chapters, from the pages 22 and 23 and see if you want to work on anything else. If not, I'm ready to move on. Yeah, why not? Let's take a look at a subject that is not pleasant, chemotherapy. Let's look at that example. It says, in computing the dosage for some chemotherapy patients, the measure of a patient's body surface area is needed. A good approximation of this area, S, so let's say 77 on page 23, S is given to us as HW divided by 3600. Okay, so let's see what they say. W is the patient's weight. In kilograms. Perfect. H is the patient's height. And it is is measured in centimeters. Please always, whenever measurement units are given, always, all the answers have to have measurement units. Okay, and what else it says? Use this information for exercises 7. Okay, if a patient's height is 170 centimeters, approximate the patient's surface area, assuming that the patient's weight is 70, then 100, and then 50 in kilograms. Of course, you already know what I'm going to do. Not because I'm lazy, it's because it's the wise thing to do. So the surface area is measured in squared centimeters. I just want to make sure it's right here. No, in squared meters. So this is in squared meters. Okay, so we're given the height. So this is the square root of the height, 170. The W changes from 70 to 100 to 50. So the height is given to us. Okay, So I have 170, and the W is basically in my calculator. I can't put W, so I'm making a point to make sure that I'm replacing it just for the calculator purpose, so you know what it is. So then I will have the answer right away with W 70, 150, and this is S, the surface area in square meters. So I'm sharing my screen.